So in this video, we're going to talk about what we call linear regression. And in linear regression is made up of two very distinct things. And that's what we call correlation, and the other thing we call least squares regression. So when we talk about correlation is just going to be when we talk about it, it's the linear strength. It's the linear relationship between two quantitative variables. And that linear relationship can be one of two things. It can either talk about the direction of the correlation, we're talking about the direction, or we can talk about what we call the strength of the correlation. We talk about the direction, we can talk about the strength. And the two variable data, when we talk about two variable data, we call that bivariate data. So correlation focuses on bivariate data. Now, we know when we talk about two variables, we have an independent variable, which in this particular case we're going to call the explanatory variable. Or in linear regression, we also call it the predictor, because it's going to predict what happens to your dependent variable. So it's also called the predictor. And in correlation, the other variable, the dependent variable, is what we call our response variable, because it's going to respond to whatever you're dealing with, whatever is explaining it. So generally, the explanatory is what we call our independent or our x variable, and the dependent is what we call our y variable. And we're going to show the relationship between these two variables using a scatter plot. So a scatter plot is used to graph bivariate data. The horizontal axis of the scatter plot is the explanatory variable. This is the explanatory variable. And the vertical axis of the scatter plot is the response variable. So when we do this, we're going to put our explanatory here. That's your x. And we're going to put our response here. That's your y. And we're going to plot that relationship as a point. So everything inside of here will be x-y pairs. Now, when we talk about correlation, remember, it's made up of two things, direction and strength. When we talk about the direction, there are three directions that correlation can have. And notice here we have different graphs for those particular directions, and we have the variables with them. So this says, as in a positive correlation, the trend of the data will go up, it'll rise. And what this is really saying, as x increases, y also increases. And here it says, as hours worked increases, your pay increases. So this is what we call a positive correlation between the two variables. We want to see if we can find a positive slope of a line, basically. In negative correlation, the slope of the line, if you try to draw this through it, will be, the slope of the data will be down. And what this is saying, that as x increases, y decreases. So it's an inverse relationship. And this says, as hours worked increases, your patience decreases. And the last thing is zero correlation. And in zero correlation, what happens here is there is no general trend up or down in the data. It's like this, basically a zero slope. So as x increases, y has no relationship with x. And this one says, as hours work increases, your shoe size has no relationship with x. And so we have three different types of directions that we can look at the general trend of data. And this is just telling me the general trend. What's happening as x is increasing, x will always increase. I want to know, as x increases, what happens to y. So for this particular data, we can draw a scatter plot, and it says that a researcher conducts a study to determine whether there's a linear relationship between a person's height and their pulse rate in beats per minute. And you notice here, your height, the height is going to be your predictor or your explanatory. So this is the x. And your response here is going to be your pulse rate, y. So we're going to plot these points, and on this graph we see that we go from the largest x value is from 68 to, our smallest is from, looks like 62 to 78. So we're going to label our axis on here from 62 to 78. I'll actually start this here, 62, and we'll break the graph here to show that we're breaking it. 66, 68, 70, 72, 76, and 78. And then our smallest pulse is from 65 to, it looks like 100. So again, because we're breaking the graph, we'll start this at 65. I'll count by 5. So we'll plot these points now. So we have the first one is at 68.90. So about right here. Then we have another one at 72.85. So about right here. And we have another one at 65.88. Here. 7100. Here. 62.105. Which will be somewhere up here. 75.98. 75 on the X, 98 on the Y, which is here. 78.70 here. 64.65 about here, and then 68.72 is here. You look at this data; it's really hard to get a grasp of where it's going, but I think that it's going to be more positive than negative trend. But it'll be a very weak negative value. We'll talk about what I mean by weak in the next part of this. So we keep going then. If we want to actually measure correlation, how strong the correlation, we call it the string, we usually call it the correlation coefficient, or the variable R. And the correlation coefficient gives two things technically. It gives the direction, which we've already seen that we can get from the scatter plot, and it also gives the strength of a linear relationship between two variables. So it gives the correlation basically between those two. We call the population correlation coefficient the Greek letter rho. That's the Greek letter rho. And the sample correlation is the value R. So we call the sample correlation R. That's what we're going to be interested in. And the value of R is always between -1 and +1, inclusive, which means it can include these values. The closer or more of a line, the linear, or the closer the linear relationship between the variables, the closer it is to, so we'll say the straighter here. The straighter or more of a line, the linear relationship between two variables, the closer the value is to 1 or -1. -1 is what we call perfect negative correlation. +1 is what we call perfect positive correlation. So that means that it's perfect. That means it's an exact line. So perfect positive, perfect negative. It's an exact line when you look at it. Values that are close to 0 implies that a linear relationship does not exist. And we saw that. So if you have values that look something like where it's just scattered out, there is no linear relationship. And I need you to really remember that correlation itself only measures the linear strength. The linear strength. There are other types of strengths that you can measure. Quadratic, cubic, exponential. But in this case, we're only interested in linear. That's what correlation measures. So I want to match the following correlation coefficients to their graphs below. Here's how we do that. In order to match these correlations, I'm going to look at how strong of a line they are and the direction in which they go. I know that this has to be a positive correlation, and it's pretty close to a line. So I want to look at the positive values and look at the ones that are very close to 1. In this particular case, that's going to be letter B. If I look at this one, this is a negative correlation. The next one to it is also negative. This one is more negative than this one. This one is closer to a line than that one. So look at my negative values. I have a negative 0.89 and a negative 0.065. The one that is closer to the line, this one that's closer to -1, is going to be this value right here. So that's going to be D. And this one will be C. If I look at these two, these are both positive, but this one is more positive than that one. So I have values of 0.47 and 0.83. That tells me that this one right here will probably be 0.83. And the other one right here will probably be 0.47. And this last one, it's very hard to see the direction here. So because it's very hard to see that direction there, we're going to say it's close to 0. That value is 8. So when you do this, what you're trying to do, if you're given values like this, you want to see how close of a line, and you want to find the direction in which they move. Now, we can find the correlation, the actual correlation, using our graphing calculators. So to do this, we need to use our list. And you're going to put the data for the x variable in L1 and the y variable in L2. So when I do that, remember I press stat and edit. I'm going to type the values into L1, the heights this time. So 68, 72, 65, 70, 75, 78, 64, 68. Type those all in, and I'm going to type the other values in the other list. 90, 85, 88, 100, 105, 98, 70, 65, 72. Make sure that they line up with each other. That way I know that 68 goes with 90, 72 goes with 85, and so forth. And now to actually do correlation, I'm going to press my stat key. And I'm going to go to calc. And I want to do linreg, number 4, ax plus b. And it's going to ask me to set two lists. So I need to do list L1, so I'll press second and 1, comma, second and 2. Close parentheses. Here we go. And there's my R value. My R value is sitting at here. R is equal to negative 0.146. So notice that the value of R, and I told you earlier we couldn't tell what it really was. It was positive, but it actually is a negative value. R is negative 0.146, and that means that it's pretty weak. This is a weak correlation here. It's not very strong. The closer it is to 1, it is strong. The closer it is to 0, it's not as strong. Some of you may not see your correlation when you do this. If you don't see your correlation, what you're going to press is second and mode. I'm sorry, just press the mode key. And right where it says diagnostic, where it says statistics diagnostic and the operation modes down here, mine is turned on. Yours may be turned off. Make sure it's turned on to green like this. So make sure that's turned on to green. And you'll be able to, and then do linreg again, and you'll be able to see your actual correlation.